just a minute and go back over some of the basics with the right triangles, but then add some other things to it. Again, the basic 6 trig functions haven't changed. Sine and its inverse, cosine and its inverse, tangent and its inverse. And so all we're basically going to be doing for these is taking wherever our reference angle happens to be given to us, that's what our theta stands for, and for a couple of these, going ahead and figuring out all 6 trig functions. Now you'll notice I conveniently left you without a missing leg or hypotenuse on each of these. So in each of them, using the Pythagorean theorem would help you out. Or maybe if you remember your Pythagorean triples, it goes a little faster. But if not, remember, if you had the hypotenuse as one of your values, you always have the option of doing hypotenuse squared minus side squared. So if I do that, I end up getting my other leg as 12. And once I have that value, now I can just roll and figure out all my different trig functions. So sine opposite over hypotenuse. Cosine's my adjacent side, again, the side that's connected to my angle. So 12 over 13. Tangent, opposite over adjacent. And then I basically start looking for my inverses. Tangents, inverses, cotangent. Flip it on over. Cosine and secant are inverses. Sine and cosecant are inverses. And I just work it through that way. However, if I have 2 sides and no hypotenuse, of course, when we went to work that, we'd do our old a squared plus b squared is going to equal what I'm looking for. So always be careful as to which sides you have to try and figure out which form of the Pythagorean theorem you're going to use. So here, 144 and 256 would be 400. So my hypotenuse ends up being 20. And I can run through this whole gamut again. Now, here's the thing I do have to watch for. It's just a little detail thing. Okay, my sine is opposite over hypotenuse. But if you can reduce whatever that fraction is in any way, shape, or form, you need to do that. So my sine's 4/5. My cosine's adjacent over hypotenuse. And I get 3/5. Tangent is opposite over adjacent, which gets me 4/3. And the nice thing about reducing right away is, now when I go to do my inverses, I already have the simplified form. I've just got to go ahead and get those jotted in. So nothing that's really going to be overly complex, especially since we've done some right triangle trig already, both in geometry and in here. But here's where we'll start stepping things up a little bit, just to kind of get us back into the swing of things. In that next section, where it says in a right triangle, angles A and B are acute. Now that's going to be a little bit important here. So they tell me that the tangent of A is 7/12. What's its cosine? Okay, well, by telling me that that's the tangent, they're telling me the opposite, and they're telling me the adjacent sides of this particular triangle. So which side's missing? The hypotenuse is. So I need to know what the hypotenuse is, but I know what these are already. So I'm going to go ahead and use the Pythagorean theorem to figure that out. Now, if you're more visual and you wanted to see a picture of this to make it click a little better for you, there's nothing wrong with drawing a picture. If you were to draw yourself a right triangle and be like, okay, this is going to be my A, Here's opposite, here's adjacent. I'm looking for the hypotenuse. That's fine. So let's see, 144 and 49 is 193. Now here's the one kicker, my decimal people. We are not going to use a decimal. You're like, but I can't do anything with the square root of 193. First, always make sure you can't. Think of some possible numbers that might go in there nicely. If you find one, cool, but I don't think you're going to find one this time. So if that's the case, and that happens to be my hypotenuse, I go, okay, cosine of A is adjacent 12 over hypotenuse. But I have one more issue. Just issue after issue with these. I can't have that radical in the denominator. I've got to rationalize it. So we'll go ahead and rationalize my denominator. So 12 square root of 193, and as we've noted before, the radicals just cancel when you do this. And I can find my cosine. So again, if you're more visual, draw the picture, find the part you're missing for, roll from there. Otherwise, just take the information and kind of work it that way. But always, always, always pay attention to whatever function you get at the start. I get cosine. That's adjacent and hypotenuse. So I go, okay, I have the hypotenuse this time. I am now looking for the opposite. So I would take the square root of each of these. So 4 minus 1 would be the square root of 3. Which would be my opposite, since they already gave me the adjacent and already gave me the hypotenuse. And once I get that calculated, if I'm looking for the tangent, I'm going to use opposite over adjacent, which would just be the square root of 3. So it's kind of just like doing a little bit of detective work, seeing what sides I'm already given and working it from there, visually or otherwise. Now, this time they're going to try and throw a twist in on you. Notice on the first two, it's been tangent of A, cosine of A. I'm using A both times. Cosine of A, tangent of A, using A both times. This time I've got sine of A, tangent of B. We'll deal with that in a second, but I still need to figure out my missing side here. So tangent is opposite over hypotenuse. So I'm going to be looking for the adjacent side, but I have the hypotenuse. So 12 squared minus 7 squared is going to get me my missing value, my adjacent side. 144 minus 49 is the square root of 95. So I've got a radical to play with. But this time I might suggest drawing a picture once you get this set. Because here's the problem we can run into. Okay, make myself a right triangle. You can name A and B whichever way you want. But if we're basing this off of A, my opposite would be 7. My hypotenuse is 12. Okay, that can at least get me my initial triangle set up. Because now, if I want the tangent of B, that would be different than if it was the tangent of A. If it's the tangent of B, it's opposite over adjacent. If it would have been the tangent of A, it would have been just the opposite. It would have been 7 over the square root of 95. So if you're ever looking for a shortcut where you don't want to draw and you get opposite letters, figure out the tangent as though it was the tangent of A and then just take its reciprocal. That works. Otherwise, drawing a picture is never a terrible idea by any means. But that would end up being my tangent for that one. So again, we're just kind of expanding the thought process a little bit. That's about all. So those last couple, because we can't go a day in here without doing some sort of a story problem. So, all right, we got John. I'm not going to get cute with this. I'm just going to get my right triangle working here. John stands 150 meters from a water tower. Okay. Because again, we talk about a horizontal distance with that. And sights the top in an angle of elevation of 36 degrees. Even if you see angle of depression with these, the angle's going to end up in the same place. It's going to end up down here. Because if it were depression, my 36 would be here, and we talked about how my alternate interior angles would get it to the same place. How tall is the tower? Round to the nearest meter. Okay, so I have an angle. What two sides am I working with? Opposite and adjacent. So if I have opposite and adjacent, I'm working with tangent. It is opposite over adjacent. And again, when you go to plug this in to the calculator, just be a little cautious. I know I'm going to multiply both sides by 150. So when I go to type this in this case, it'd be 150. Make sure I'm in the right mode. I am, okay. 150 times the tangent of 36. And since we're going to the nearest meter, looks like that building's about 109 meters tall. So again, pictures can help. So one more. Again, I'm going to save my drawing skills for another time. Jessica stands 150 feet from the base of a tall building. Okay. She measures the angle from her eye to the top of the building to be 84 degrees. If her eye level is 5 feet above the ground, okay, we're going to have to talk about this a little bit. How tall is the building? There's two ways you can tackle this. You can either ignore the 5 at the start of the problem, just solve this like you normally would. So again, I'd have opposite and adjacent. So I'd do 150 times the tangent of 84. So if we were going to the nearest whole value, we'd be at like 1427. But then I'd have to remember, that's from her at eye level, and they said her eye level was 5 feet above the ground. So I'd have to add 5 to it. Now, if you're one of those people that you would tend to forget at the end, you do the problem, you forget about the 5, and then you'd be like, crap, I missed this. The other way I could set it up for myself, if I didn't want to get this messed up, would be to set it up as the tangent of 84. But if you're doing it just with that triangle at the time, you'd be subtracting 5 from it, because you've got this 5 you're not taking into account. You're like, wait a minute, why wouldn't I be adding it? Just watch. When I cross multiply, and I'd add the 5 over. And you notice I get the exact same answer, because I'd do 150 times the tangent of 84, but I would just add it in right away to make sure I don't forget. But otherwise, this is pretty straightforward type stuff. We're going to start pushing towards some more things. We're going to get into drawing angle measures and finding reference angles and doing some more like real triggy type stuff here. But this will kind of get us a head start on that, and then we'll start getting into those tomorrow.